Welcome to all in exam race. This is the magnetic effect of current and magnetism. We are here for para, dia and ferromagnetic substance. We will see what are the magnetic substance, what are their properties, and we will separately see what actually a paramagnetic substance and how it is differ from diamagnetic. Similarly, we will see what is ferromagnetic and how it is differ from paramagnetic and diamagnetic. Also, we will see their properties separately. And we will see the problem that is based on paramagnetic, ferromagnetic and diamagnetic substances. Before moving to the story related to the paramagnetism, diamagnetism, ferromagnetism, you must know few terms that is going to be used in all these things. Few important terms. So we start directly with the terms, and that is related to your magnetic materials. Okay. So first is your magnetizing field. Okay, magnetizing fields. Now, this thing that come in our mind, that what is magnetizing field? So whenever the word magnetizing field, you know, where a magnetic material is placed in magnetic field. Okay, a magnetic material. Suppose this is a magnetic material and placed in magnetic field. Okay, then a magnetism is induced in it. So magnetism is a property of magnetic field that is induced inside this you can say material, magnetic material. So what is magnetizing field? It's a magnetic field that exists in vacuum. Okay, in vacuum, and induces magnetism. Okay, as simple as that. And if I give you example, you know, we have seen toroid, we have seen solenoid. So toroidal or solenoidal current conductor carries current, and whenever this plays in vacuum, so that toroid or a solenoid having the number of turns have certain magnetic field, and that magnetic field is due to the magnetizing field, or you can say the magnetic field inside a toroid and solenoid is what we call magnetizing field, that is caused by so-called current of the solenoid. Clear? Second thing that you must know is magnetic induction. Okay. In this magnetic induction, what is there? Again, you think about your toroid. This is your toroid. Okay, and over that currents are there. A layer of, not actually the layer, you can say the currents are there. Loop of the current. Okay, so loop of the currents are there, and in this what you learn about is that whenever the current flows, or whenever this toroidal solenoid is bounded by the ring of the magnetic material under the influence of the magnetic field and the magnetic moment of the atomic current loops. Okay, and magnetic moment magnetic material tends to align themselves. For example, if you cut it and see the cross section, if you see the cross section, you can see the current is spinning in it. Okay, the current is spinning in it like this. Number of loops are there. Okay, number of loops are there, and if it is spinning in this way, what happened finally is that whenever the spinning of currents are there, they will give rise to the net current, and that net current rise is on the surface of the wire. Okay, and that surface of the wire has your induction current. Okay, or what we call magnetization. You can say magnetization surface current, and this is what we call IM. Clear? And this magnetization current leads to your magnetic field inside the material, which is what we call mu naught and IM. So what actually the magnetic induction in it? So magnetic induction is defined as the total number of magnetic line forces crossing per unit area normally through a material. Okay, so all in all, what we can say, this magnetic field Bm is the total magnetic field inside the magnetic material, which is the sum of the external magnetic field and additional magnetic field produced due to the magnetization of material. And this is what we call magnetic induction. Okay. Third one is magnetizing field intensity. Okay, so what it is, magnetizing field intensity, it is very important. So simply if you say what it is, so the ability of magnetizing field, okay, ability of magnetizing field to magnetize a material medium is what we call the magnetizing field intensity, which is denoted by H vector. Okay, this is the magnetizing field intensity, or simply you can say magnetic intensity. So if you say what is magnetic intensity, it is defined as the number of you can say current or number of ampere turns, which is N into I, that is flowing through a unit length. Okay, flowing through unit length. So H is equals to Ni, but you know what is B? B is equals to mu naught Ni, but Ni is H, so B is equals to mu naught H, and from here you can say H is equals to, if it is B naught, you can say it's B naught over mu naught. This is your magnetizing field intensity. Okay, and you can easily find the dimension also, and unit is ampere per meter. Clear?